Now, principle of mathematical induction state that if Pn be true for say n equal to n naught, that is the least value of n. This one, very simple one, for n equal to 1, 2 into 1, that is 2, we conclude P1 is true. 2 is even number. Next, this is called basic step. Now I am going to start new topic. Already I have written on the board mathematical induction. First let me introduce like this. There are various results formula in mathematics. Those cannot be proved directly. An important method by which we prove those is mathematical induction. We use the principle of mathematical induction to prove those. First of all, let me take a simple example. In lower classes we say 2n is an even number, 2n plus 1 is odd number, where n is natural number. Now, if we say we prove 2n is an even number, where n is natural number. Now we can verify by putting values of n starting from, since natural numbers starting from 1, then putting, if we put n equal to 1, what we get? 2 into 1, that is equal to 2, which is even. Putting n equal to 2, what we get? 2 into 2 equal to 4, then 2 into 3 equal to 6, etc. These numbers are even. Now, if that expression be complicated and it is said a given property to be hold for that expression, then it will be quite difficult to prove that directly. For that, we apply the principle of mathematical induction. First, let me discuss the principle of mathematical induction. Let the given result or given formula involving n, where n is a natural number, is denoted by Pn. For this example, let Pn to n is an even number like this. The mathematical statement is this one. First we take Pn, then for least value of n, generally n is natural number, but not for all formula or expression. The condition will be mentioned where n is greater than equal to 4 or is n is greater than equal to 2, like this. And for the least value, we first verify that. Then if we see the statement involving two parts, that may be equality or an expression, we verify that whether it holds or not. If it holds, then we make the comment P1 or P2 or P3 or P4 as the minimum value of n is true. Now, principle of mathematical induction states that if Pn be true for say n equal to n naught, that is the least value of n, and Pn plus 1 is Pm plus 1 is true by considering Pm true, then by the principle of mathematical induction, it is written in short by PMI. Principle of mathematical induction, in short PMI. By the principle of mathematical induction, Pn is true. Pn is true where n greater than equal to n naught, any natural number. Follow that. Mathematical statement is Pn where n is natural number, and this is true for the least value n naught, that is also positive integer or natural number. Then first of all we verify this one, then we consider Pm be true, Pm where m is any natural number greater than n naught, m this one. Now taking to be Pm to be true, we show by actual calculation Pm plus 1 is true. Now what we get? Say for m equal to 3, the statement is true. That is basic step. We call that basic step. Now we assume Pm true where n is greater than n naught. I have started showing Pn naught true. m naught is true, then we consider Pm to be true where m is this one. Obeying this rule, then we show by actual calculation Pm plus 1 is true. Then we think like this: if P4 is true, then by actual calculation P5 is true. Then we can show P6 is true. Then we apply this principle of mathematical induction and conclude that Pn is true. Now, to understand this, we take examples and solve problems. First of all, I discuss this simple one. This one, very simple one. For n equal to 1, 2 into 1, that is 2, we conclude P1 is true. 2 is even number. Next, this is called basic step. Then comes inductive step. Let Pm be true. Therefore, 2m is an even number. For Pm plus 1, 2 into m plus 1, that is equal to what? If we calculate 2m plus 2, now already we have taken 2m is even. Now 2 is added to that even number, and we know if we increase an even number by 2, we get the next even number. For example, 6 is an even number. If we add to it, then we get 8, which is the next even number after 6. Therefore, this is even number. Therefore, Pm plus 1 is true. Then we mention the principle of mathematical induction. Therefore, by Pmi, I write in short, Pmi, Pn is true. Therefore, final conclusion, 2n is even number. Is an even number. N is any natural number. Now I shall follow these steps. I take now few more sums to discuss. If I call that example 1, then example 2. To show 1 plus 2 plus 3 plus 4 n is equal to n into n plus 1 whole by 2, where n is any natural number. Students of 11-12 standard already got this one. They have got this sum in the topic AP. Now we are going to prove this with the help of principle of mathematical induction. First step is this. We follow like this. Step 1. Let Pn write this whole 1 plus 2 plus 3 plus n is equal to n into n plus 1 divided by 2. For n equal to 1, left hand side will be just one number 1. RHS will be equal to, put n equal to 1 on the right part. Therefore, it will be 1 into 1 plus 1 by 2, that is equal to 1. Thus, we see LHS equal to RHS. Therefore, LHS equal to RHS. Therefore, the conclusion P1 is true. We call this, already I have mentioned, basic step. Basic step. Now, the inductive step. Write out this one. This is step 2. Let Pm be true. That is 1 plus 2 plus 3 plus m. Just you replace m. In this result, you replace n by m. That is m into m plus 1 divided by 2. Now, by actual calculation, we shall show Pm plus 1 will be true. We write like this: for Pm plus 1, LHS part will be 1 plus 2 plus 3 plus dot 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 m. Then m plus 1 is to be written m plus 1. This one for Pn. Now already we have got the value of this one. We put that m into m plus 1 by 2 plus m plus 1. Already we have taken sum of this is this one. I have put that value. Then m plus 1 is added. Now to calculate this, m plus 1 is common factor. M by 2 plus 1. That is equal to m plus 1 into m plus 2 by 2. Now we find that product is of two successive numbers, m plus 1 into m plus 2. This is m plus 1 plus 1. This is of this form, m plus 1, m plus 1 plus 1 whole by 2. That means numerator is product of two successive numbers and divided by 2. I write like this, which is of the form n into n plus 1 by 2. Note that of the form, this form, original this one, oh sorry, it is written wrongly, n into n plus 1 by 2. form. I'd have this one here, no need, which is of the form n into n plus 1 by 2. We took Pm to be true, and what we find? Pm plus 1 is also of that form. Therefore, conclusion is Pm plus 1 is true. After this step, the conclusive step, I have this one. Or final step, therefore, by the principle of mathematical induction, Pn is true. N is of course natural number, and finally we write the statement or the formula to be proved originally. Therefore, 1 plus 2 plus 3 plus n is equal to n into n plus 1 by 2. N is any natural number. Therefore, the sum is solved.